Look around any modern factory and you will see robots worth hundreds of thousands of dollars being controlled by a dusty 10 years old desktop PC sitting on a workbench. It's a recipe for complete disaster. But a new tech trend is fixing this chaos. Welcome to the world of IDC, Industrial Data Center. Today in this video, we will see how this technology works, a brief idea about its architecture, and why it is so crucial in the world of OT like oil and gas or inside manufacturing plants. An IDC, which is Industrial Data Center, is a purpose-built computing environment deployed within or very close to industrial facilities such as factories, power plants, refineries, warehouses, and utilities. Unlike traditional enterprise data centers that mainly support business applications like email or ERP system, an IDC focuses on operational workload that require real-time data processing and extremely high reliability. It acts as the local brain of an industrial environment, collecting data from machines, sensors, PLCs, and control systems. Then processing that data instantly to support automation, monitoring, and control decisions. The defining characteristic of an IDC is its proximity to industrial operations. By being located on site or at the edge, it minimizes latency and ensures that critical systems continue to function even if connectivity to the cloud or corporate data center is slow or unavailable. This is essential in industrial environment where milliseconds matter and downtime can lead to safety incidents, production losses, or regulatory issues. An IDC also bridges the gap between information technology and operational technology. It allows industrial systems to benefit from modern computing capabilities such as virtualization, analytics, and cybersecurity, while still respecting the reliability and determinism required by the OT systems. In simple terms, an IDC brings the power of modern IT directly into the industrial world, enabling smarter, faster, and safer operations. Why industrial data centers are needed? So, industrial data centers are required because traditional centralized data center and cloud only architecture cannot meet the unique demands of industrial operations. Industrial systems often need real-time responses to events such as machine faults, quality deviations, or safety alarms. Sending this data to a distant cloud and waiting for a response introduces latency that can be unacceptable in critical environment. Another key reason for IDC adoption is reliability. Industrial facilities must continue operating even during network outages or limited internet connectivity. And IDC ensure that core automation, monitoring, and control functions remain available locally, reducing dependence on external networks. This is especially important in remote sites such as mines, oil rigs, or substations. Security is also a major driver. Industrial environments are increasingly targeted by cyber threats and mixing OT systems directly with enterprise IT, or the internet can increase this risk. An IDC enables proper network segmentation, controlled data flows, and the deployment of specialized OT security tools. Additionally, as industries move toward smart factories, predictive maintenance, and industrial IoT, the volume of data generated by machines grows rapidly. Processing all this data centrally is inefficient and expensive, making local industrial data center a practical and necessary solution. Key requirement of an industrial data center. An industrial data center has several critical requirements that distinguish it from a traditional IT data center. First, it must be designed for harsh environment. This includes tolerance for dust, vibrations, heat, humidity, and sometimes limited physical space. Hardware used in an IDC is often ruggedized and industrial grade to ensure long-term reliability. Second, high availability is essential. Industrial processes often run 24 by 7 and downtime can be extremely costly. Therefore, IDCs require redundant power supplies, UPS systems, backup generators, fault tolerant servers, and resilient networking. Maintenance and upgrades must be possible without disrupting operations. Third, cybersecurity and network segmentation are mandatory. An IDC must securely connect OT system with IT and cloud platforms while preventing unauthorized access. This includes firewall, intrusion detection, secure remote access, and continuous monitoring. Finally, scalability and manageability are important. As industrial environments evolve, the IDC must support new applications such as AI based analytics, predictive maintenance, and digital twins, while being centrally managed through modern tools and platforms. So, to talk about simple architecture and data flow, the architecture of an IDC is typically organized around a simple and logical data flow. Machines and sensors generate data, the IDC process it locally, and selected data is sent to the cloud or central data center for advanced analytics and long-term storage. At the lowest level, industrial devices such as PLC, robots, and sensors continuously produce operational data. This data is transmitted over industrial networks using protocols like Modbus, Profinet, or OPC UA. The IDC sits directly above this layer and perform edge processing. It hosts applications such as SCADA systems, historians, local analytics, engines, and security platforms. By processing data locally, the IDC enables fast decision making, alarms, and control actions without relying on external systems. Only relevant filtered or aggregated data is forwarded to the cloud. The cloud or central data center then provides higher level capabilities such as machine learning, fleet wide analytics, centralized dashboards, and long term reporting. This layered approach combines the speed and reliability of local processing with the scalability and intelligence of the cloud, making the industrial data center a cornerstone of modern industrial digital transformation.